this last section talks about dating the solar system. And so we're going to talk about radiometric dating of rocks. So let's picture a rock, and the rock is going to form with trace amounts of a radioactive material. So it's formed with a trace amount of, let's say, potassium. While that rock is solid, and some of the potassium will change from a red dot to a blue dot. And in this case, potassium would change into argon. So after one half-life, half of the potassium is changed into argon. If you wait another half-life, half of the red dots that were left will change into argon. So all you really have to do is compare the ratio of red dots to blue dots, and that tells you how long the rock has been solid. And the half-life of potassium is about 1.25 billion years. So to go from here to here is 1.25 billion years. To go from here to here would be 2.5 billion years. So when you're radioactively dating rocks, you find a pair of chemicals that are related in this way, and if a parent radioactive chemical and the daughter, what it's going to change into, and you just compare the ratios. There's a problem, is a lot of these daughter products, these blue dots, are gaseous and they don't condense, which means that if you were to melt this rock again, the red dots would stay behind because they're solid, but the blue dots would be allowed to escape. So if you end up melting a rock, you restart the clock, and then it's going to tick, tick, tick. So radiometric dating only tells you the time since the rock last solidified. And on Earth, that's a problem. Because of all the rocks on our crust, they've gone through volcanoes several times since the beginning of the Earth. So there are no rocks left on the surface of Earth that are original, that have been solid since Earth formed. So you go find an original rock, one that's been solid and untouched since the beginning of the solar system. You go get yourself an asteroid. You cut open the asteroid, you capture these two chemicals and you compare their ratios, and you find the age of the solar system. 4.55 billion years old. And it's not just potassium to argon. There are many other pairs of chemicals that you can do this to, and they give you the same answer. 4.55 billion years old. The moon rocks are a little bit younger than that because the moon rocks had some tectonics. Right? So here it is in graph form. You start off with only your parent's radioactive element, in this case potassium, and it decreases and decreases and decreases, and it's turning into the daughter element, argon, and it increases and increases. And all you do is when you get your rock and you cut it open, you find the ratio between the blue and the red. It tells you the time since the rock was formed. If the rock melts, the clock restarts, right? Because you're only going to start off with the solid radioactive material because all of the other argon has escaped as a gas, and you restart the clock.